to unified conferencing.
Okay, so that one tells you that your recording's in progress. Okay. So, I'd like to introduce Mr. Lewandowski. Take it away.
Hello everyone, my name is Tim Lewandowski. I am a teacher I do adult ed at the Lifelong Learning Center here in Missoula. I have a bachelor's degree in mathematics. I went to school, I graduated in 2014. It took me a long time to get my math degree. It took me 6 years and I struggled in not in every facet, but at all the different levels. So I understand some of your frustrations that you may or may not have with mathematics, and I'm hoping to help you guys overcome some of those fears and be more confident in your skills, and hopefully we can hammer out this ACT math test successfully. I suppose we should start with what's on the math test. So I have a small PowerPoint here covering those sorts of things. What's going to be on it? As you can see here, I've broken it down into six general categories. We're going to have some pre-algebra, some elementary algebra, intermediate algebra, coordinate geometry, plane geometry, and trigonometry. Those are about the six different main topics that you will see on the ACT test. You'll notice here at the bottom I've written story problems. You will see story problems in all of these categories. They will present all of these different ideas will be presented in a story problem in one way or another on the exam. So it's important to be prepared for that, be ready to pick out information and set up equations so that you can solve some of these story problems. First section will be pre-algebra. You'll notice I have a bunch of numbered problems. I sent an exam a while ago. It was a practice exam. I sent a practice exam a month ago or two to you guys in hopes that you guys received it, hoping that you guys had a chance to look through it, and hopefully when we are together face to face you will have some questions already established so that we can talk about those things more. Pre-algebra. What is pre-algebra? It's basically your basic arithmetic. These are the things we've been working on since first grade and on. A lot of these ideas, a lot of these words you'll see up here are detailed definitions, but a lot of these things you guys should already be comfortable with. And you've been working on them for a long time. So pre-algebra is arithmetic, basically. We're going to learn how to add, subtract, multiply, divide. We do all those operations with whole numbers, decimals, fractions, and integers. Some of the vocabulary that I may be using right now may be a little confusing, but we'll certainly talk about what all of these different things mean. We have arithmetic operations with squares and square roots. We use different kinds of notation. We either have exponential notation, standard notation, or scientific notation. These things are all things that hopefully you've heard of and have some sort of comfort levels with. Ratios, percents, and proportions. That's another big topic of pre-algebra. Calculating percentages of different numbers, setting up proportion problems so that you can find out what is to what as something else is to something else. Counting techniques, absolute value, and of course I noticed on the exam there's quite a bit of simple probability and descriptive statistics. If you notice at the top of my slide here, I've numbered all the numbers on the practice exam that I sent that fall into that category of pre-algebra. So we'll work on those things. Another good chunk of the test is going to be elementary algebra. As you can see here, there's quite a few problems. It gets a little bit more intensive algebraically at this level. We start solving for x, we start setting up equations using variables, and then we have to solve those problems that we set up. Once again, there's a list of all the problems that I went through on the exam that were under the topic of elementary algebra. Algebra is a big theme, as you can see here. We get a little bit more intense with our algebra. We have to understand the quadratic formula, rational and radical expressions, absolute value equations and inequalities, patterns, recognizing patterns, solving systems of equations where we have y equal to some other, y equaling some equation with x, and then y equaling another equation with x, two different equations, and how do we put those together and solve them to find solutions when both equations use the same variables. Functions, roots, complex numbers, all of those things I found on the exam. Not as much as some of the other things. Complex numbers, I believe there was one question on there, but it's good to have an idea of what those are and how to manipulate them. Another big portion of the test is coordinate geometry. This one is my favorite topic. I really enjoy graphing lines using the coordinate plane, the XY plane. So we need to know the relationships between equations, graphs, and tables, and how they all work together. Points, lines, polynomials, circles, other curves, all on the XY axis. We need to know how to graph these things, how to look at equations and pick out slope, pick out y-intercepts, x-intercepts, figure out how to draw a picture from an equation. So those are things we'll also work on. Plane geometry, this is going to be your shapes, your plane figures, circles, triangles. Oh, excuse me. Lord, sorry. Plane geometry. These are going to be your formulas. So you're going to have to, I do not think the ACT gives you any sort of formula sheet. You'll have to know a lot of the formulas that are used to solve for area, solve for perimeter of different sorts of shapes: circles, triangles, rectangles, parallelograms, and trapezoids. Plane geometry is also going to require us to know a lot about angles and how supplementary and complementary angles work together. And how, or what it means to be supplementary and complementary, and how we can solve other angles knowing something about one other angle. And then, of course, there's going to be three-dimensional shapes and figures. We'll have cones and pyramids and cubes, and we'll have to know the formulas for solving for volumes or surface areas, which would be geometry in 3 dimensions. The last part of the tests that you can expect to see problems for is trigonometry. Trigonometry is the relationship between a right triangle and its interior angles versus its side lengths. Hopefully some of you have heard the term SOHCAHTOA. That's your sine, cosine, and tangents. These things will all be, hopefully you guys have calculators that can help you find sines, cosines, and tangents of different triangles. and we'll talk about how to use SOHCAHTOA and nail down some of these trigonometric problems. Notice here that there is not very many questions. Trigonometry is not something that I'm going to focus a lot on during our time together. I'll spend a little bit of time on it, but for the most part it's not a big part of the exam. You can expect trig to be probably 3 or 4 questions on a 60 question test. So those are the things we can expect to be on the exam. I suppose I should talk a little bit about what the setup for the exam is. It's a 60 question test. It is a 60-minute test, which means if we do that math, we get 1 minute per question. So we have to be confident in our skills. We have to move quickly. We have to and use different test-taking strategies. I'd like to talk about some of those strategies for a little bit. One strategy for the ACT would be to answer all the questions. On the ACT exam, you do not get penalized for wrong answers. You get penalized, you do get penalized. You get 0 points for wrong answers. You get 0 points for no answer. With that being said, if you get a correct answer right, you get 1 point. So even if you don't know the answers to some of these questions, it would behoove you, or be to your benefit, to answer all of the questions, because you would at least give yourself a shot. Even a guess is better than nothing. You have to move fast, so I would suggest running through the tests one time and answering all the questions that you feel comfortable with and confident about right off the bat. And then of course, when you're done with that, go through it a second time and answer questions that are a little bit harder for you. And of course, make sure you leave yourself 2 or 3 minutes at the end to make sure all the answers have been completed, or all the questions have at least been answered to the best of your knowledge, even if it's a guess. Other strategies. I need my book. Totally brain farting on other strategies. I'll be right back.
You're still recording.
What's that?
You're still recording.
Oh, I know. This is not the well, it's one of the weirder things I've done. It's okay. A couple of other strategies would be to perhaps start with the problem and work backwards. It's a multiple choice test, so all of your answers are going to be right in front of you. There's lots of times where you may want to, if you were to say solve for x and you have a bunch of numerical answers right in front of you and you can't work the equation backwards to get x isolated on one side of an equation and all of your other constants on the other side, if that becomes too difficult, you can always use the numbers that you've been given in your multiple choice answers and plug them in and see how they work out. Use your calculator. You are allowed a scientific calculator on the exam, so understanding how to use it and its different capabilities would be beneficial to you, and we will definitely talk about a lot of the calculator uses as we actually start doing some math problems together. So working your way backwards, that's a good strategy sometimes. budgeting your time, making sure if you read a problem and you decide that it's just too hard and you have no idea what to do, move on to the next one. The ACT exam is not an exam where most exams you'll take, right, are start with easy questions and work all the way to the harder questions. The ACT exam is not set up like that. It's going to be set up to randomly. There's going to be easy questions, and then they'll get harder, and then they'll get back to easier. So I wouldn't suggest working consecutively through them and working on getting a long ways on number 20 or 22 and then just being stuck and forgetting about it. There's a good chance that the questions in the 30s and 40s are going to be easy, more along the level that you are comfortable with. And so making sure that you read all the questions and answer the ones that you know is very important when taking the ACT. All right. So that's what's going to be on the exam, I do believe. Like I said, I've sent you a practice exam, so hopefully when you have time to look through that, you'll be able to gain some questions, and you'll have a better understanding of what we need to work on and what you would like to be getting from me as an instructor. But it would be really helpful if you guys could work through that. I don't expect you to work through it in an hour. I expect you to take your time and do your best, and hopefully you guys can bring me questions when the time is appropriate. That's the end of my first PowerPoint.
Okay.
I have another one where we would start on pre-algebra, and I could use. Hello everyone, welcome back. We're going to start today with pre-algebra. So we're going to talk about our arithmetic operations for ACT math prep. Pre-algebra problems, we decided that those were going to be most of our arithmetic problems. On the exam that I gave you, these numbers up here, I decided all fell into the pre-algebra category. Once again, pre-algebra is our basic arithmetic operations being adding, subtracting, multiplying, dividing. And then we're going to do this with all the different types of real numbers that we have. So we have whole numbers, decimals, fractions, integers, and so we need to be able to do those operations with all of those things. So I'm going to do a couple of practice problems from our practice test that I have, and we're going to learn how to do some math, for sure. This first section here is our real number system. I like this photo for a couple of reasons. It's like a Venn diagram. You can think of these things as different sets. You can imagine all of our numbers are in here on the number line, right? So we have natural numbers, which are our natural counting numbers. 1, 2, 3, they're natural numbers because we find them in nature. They were our first numbers. So 1, 2, and 3 fall into the category of natural numbers. After that, we have whole numbers. Whole numbers include the natural numbers, but as you can see here, they do not include the integers that are out here. So our whole numbers are 0, 1, 2, 3, and so forth. Then we have this interesting funny word right here, integers. You'll find that on the test, used that way, and it's important to know what an integer is. An integer is your whole numbers and your natural numbers, 1, 2, 3, 4, and so on, but they also extend in the other direction. So our negative numbers, -1, -2, -3, all of these things, as you can see the circle, everything in here is an integer. And then we have our rational numbers. So our rational numbers are our fractions. Rational numbers are, by definition, are considered an integer divided by another integer. So we have 1/2, 2/3, 3/4. Any number that can be represented as a fraction is considered a rational number. And the final piece to our number line, which makes it continuous, is our irrational numbers that you'll see right here. Numbers like pi, e, and the square root of 2. They have decimal points that never end, that are never repeating. That's the definition of an irrational number. If you think about the number 2, where's that at? 2/3 right here. If you type that into your calculator, you're going to get 0.66666666 going on forever and ever and ever. It's not irrational because it can be represented as a fraction, 2/3, but it is a non-terminating decimal. It goes on forever and ever and ever. These irrational numbers have no repetition in them. They go on forever, but it's always random. So that's the difference between our natural, our whole, our integer, our rational, and our irrational numbers. All of these numbers can be found on our number line, and it's important to know where they are and how to find them so that when we're trying to solve math problems, we know what kind of numbers we're looking at. Also, a very good idea here is that I've noticed in my experience in time doing mathematics, but depending on what set your numbers fall into is going to kind of determine how difficult your problem is. If you're working with just natural numbers, it's generally pretty easy and it's pretty intuitive, and the things that we're used to doing are the things that we generally are supposed to do. So it feels right. When we get to our rational numbers and fractions, simplifying them, comparing them, adding or multiplying, dividing or subtracting them is a lot more trickier with rational numbers than it is with natural numbers. And obviously it's way more trickier with irrational numbers than it is with any of these down in here. So it's important to get comfortable with the different types of number, knowing the definitions, and realizing that our number line has been broken down for us into multiple different categories. It's very strict definitions for every piece of that number line. We're going to start today by doing some fraction problems. Everybody's least favorite things is fractions. I've thrown up some rules to remember here on my PowerPoint slide. When adding, subtracting, or comparing fractions, that's when we want to find our common denominator. When doing any of those three things, adding, subtracting, or comparing fractions requires the common denominator. And I'm going to do a couple of problems for you here in a moment, but we're going to talk about this slide. When multiplying fractions, that's the most intuitive thing that you can imagine. Imagine if you have 1/4. We know that that's 1/4, right? 1 divided by 4 is 1/4. Well, if you have 3/4 and you multiply that, it's 3/4 of a dollar, right? 0.75, 3/4. So 3/1 times 1/4 is 3/4. You're combining the numerator to the numerator and the denominator to the denominator. It's the most intuitive and easiest thing to do with fractions. Even though adding and subtracting is generally easier with whole numbers, when it comes to fractions, multiplying them is actually easier. When you divide fractions, it's actually easier than adding or subtracting because we multiply by the reciprocal. What is the reciprocal? It's the fraction flipped. So the reciprocal of 3 is 1/3 because you can represent 3 as 3/1, and if you flip that fraction you get 1/3. So when we multiply while dividing fractions by the reciprocal, and we follow the rules for multiplying. We flip the fraction and it's top to top and bottom to bottom. There's a little bit of a caveat here when you're playing with fractions. When multiplying or dividing fractions, our fractions must be in either proper or improper form. So what does that mean? Proper fractions are your 1/3, your 2/5, your 4/9. The thing they all have in common is the numerator is smaller than the denominator. That's a proper fraction. An improper fraction is just the opposite of that, where the numerator is larger than the denominator. What you don't want when multiplying or dividing fractions is mixed numbers. You cannot have 3/2 times, or 3.5 times 2 1/3. You can't do the 3 and the 2 and then the fractional piece. You have to convert these things to one fraction form and then stick to the rules. Of course, simplify all your fractions when you're done. And we'll actually do a couple of practice problems right now so you guys can see what I'm talking about. So here we are, camera 2, and we are going to add, can you see that? No. Add, which one do I want? 5/6 plus 3/5. Now, if you remember back from my slide, I told you that if we were going to add or subtract or compare fractions, that we are going to need a common denominator. So the first thing I'm looking at is, what am I trying to do to these fractions? I don't even care what these fractions are. What I'm interested in right now is, what am I trying to do to them? And I have a big old plus sign there. So I know that I'm adding fractions. And I know that if I'm going to add fractions, that it requires me to have a common denominator. So how do I get a common denominator? The first thing, so a way to always get a common denominator is to take the denominator you see on one fraction and multiply it top and bottom to the other fraction. So now I have 5/6 plus 3/5, but I'm going to change these fractions into something with a common denominator. I'm going to multiply top and top, bottom to bottom. 5 times 6 gives us 30. And notice it's 5 times 6 on the bottom for both of these. 5 times 5 happens to be 25. Last I checked. And 3 times 6, 6, 12, 18. So I've turned 5/6 into 25/30. And to prove to you that I haven't changed anything, I would like to show you on my calculator. Hopefully you guys can see that. But if I type my fraction 5/6 in there, I get the decimal point 8333333. And to make sure that I haven't changed anything, I'm going to check that with my new fraction that I've decided was 25/30. And sure enough, you'll see that I get the exact same decimal. So 5/6 and 25/30 are the exact same number, just with a different denominator. We'll beat this to death a little bit. There's 3/5, 0.6, and to make sure that my new fraction is equivalent, I will type it in as well. And sure enough, there it is. So 3/5 and 18/30 are the same number, 0.6. Now that I've done this, now that I have a common denominator, I can move my plus sign to the top, and everything is going to be over 30. 25 plus 18. 25 plus 18 is 43. So I have 43/30. Of course, now my fraction is improper. And that may be done. You may be done. You may look through your answers and see if that's a choice. Generally, it's not, though. They'll want you to take it one step further, so we'll actually have to do this division here. 43 into 30. How many times does 30 go into 43? One time. and you would have 13 out of 30 left over. So 5/6 plus 3/5 is 1 and 13/30. So that was adding fractions. The same goes for minusing fractions. Everything's pretty much the same. You would move it up and you would do 25 minus 18 if it was a minus. And then simplify. So here we'll move on to multiplying fractions, which I told you was easier than dividing fractions, or than adding or subtracting fractions. And if you guys have more questions on this or would like to see me do it again, please just let me know. You can email me, or we can work on more practice problems during our time together. If you guys are uncomfortable with this process, please let me know. It does take practice, but the process is always the same. So once you get it, it's just like riding a bike. Multiplying fractions. Can we see that? Barely. There it is. Multiplying fractions. So we are going to multiply, I don't know, 3/8 times 4/9. And like I said, numerator to numerator over denominator to denominator. Excuse my sloppy handwriting. So here we go. What's 3 times 4? 12. And what's 8 times 9? 72. Yes. Got that one. And then I think, of course, we can simplify that down a little bit further. I think 72 and 12 are common. I think that 12 goes into 72. So if I divide this by 12, I get 1. And if I divide the bottom by the same 12, I get 6. So 3/8 times 4/9 is 12/72, which simplifies to 1/6. So that's multiplying fractions. It's very intuitive. It's the easiest fractional thing you're going to experience. Finally, we have division. And it too is pretty simple. We're going to divide 4/7 by 8/9. So the rule that I had written in the PowerPoint was multiply by the reciprocal. Another way I've heard of it is called keep, change, flip. The reciprocal of 8/9 is 9/8. So I'm going to hold on. I'm going to keep 4/7. I'm going to change the divide to times, and I'm going to flip this fraction. And then we're going to do it just how we would if we were multiplying fractions. So 4 times 9 is 36. And 7 times 8 is 56. So there we have 36/56. 4/7 divided by 8/9 is 36/56. The last thing we can always do is simplify our fractions. For me, I noticed that these things are both even, so I'll cut them in half. So I have 18/28. I noticed that those two are still even, so I can cut them in half again. 9/14. and that will be my final answer. I do not think that 9 and 14 have anything left in common. So 4/7 divided by 8/9 is 9/14. So that's fractions in a nutshell. Multiplying, dividing, adding, and subtracting. Also, like I said, when you compare them, you need a common denominator. When you're comparing fractions, if we want to know if 5/9 compares to 7/10. Once again, we need a common denominator. So I'll steal one from one side and multiply top and bottom, steal the other one from the other side. Notice my denominators are now 90. I get 50. 63. So 63, or 7/10 rather, is greater than 5/9. So there's fractions in a nutshell. Please, if you have questions, shoot them to me and I will happily answer them. And pause. Can we pause?
Mm-hmm.
Right, so we just talked about fractions. Hopefully these are things that you guys have all seen before and are comfortable with. The idea here is to give you a refresher on how we go about it. And then, of course, as a test-taking strategy, if you are comfortable with your skills with fractions, then perhaps a good idea would be to find the fraction problems first and work through them as quickly as possible, and so that they're out of the way and you don't have to worry about them anymore, and you can continue working on this very long exam. Notice the numbers that I noticed on the test that were important towards fractions were number 18 and 32, so not very much in the middle of the exam. So you don't know where these things are, but if you can find them and you're comfortable with your fractions, hammer them out and be done with them. The next thing I would like to talk about is the rules to remember for integers. Integers. There's going to be integer problems on there. Some of the things that you may or may not remember. A negative times a negative is always a positive. A negative times a negative is a positive, but two wrongs don't necessarily make a right.
You can stand in front of your words.
Yeah, I'd like to.
I know.
A negative times a positive is a negative. The negative wins that battle. So basically you're counting your negatives when you're multiplying numbers. If you have an even number of negative numbers, then your answer is going to be positive. If you have an odd number of negative numbers, then you are going to have a negative number as your answer. When it comes to plussing and minusing integers, a number minus a negative number requires addition. So here's my example. 3 minus negative 5 is actually 3 plus 5. Right? We put our two negatives that are right next to each other and put them together. I don't know if this is helpful, but for me, I always realize that we can't operate on an operation. So I can't minus a minus. So what I do is I put those two negatives together and make it a plus right there. So 3 minus negative 5 is actually 3 plus 5, which equals 8. The last thing is a number plus a negative number requires subtraction. So if I have 8 plus a negative, once again, I think to myself, I can't operate on an operation. So I think to myself, which operation wins this battle? Well, it's the negative. The negative wins this battle. 8 minus 5 is equal to 3. So these are the basic rules for integers. I have a couple of thought I did. Yeah. No, I think that about covers it. We have to be careful. There are times where, well, it's mostly this case right here, in the number 3 here. That's mostly the case. People want that to be a negative answer generally, and it's a positive. So let me know if you guys have questions on integers and adding and subtracting, multiplying and dividing by negative numbers. Ooh, a big one to know, scientific notation. Scientific notation involves moving decimals. Scientific notation is used by scientists who are dealing with extremely large or extremely tiny numbers. This is a better way of notating different numbers, right? Mathematicians are lazy, so we don't want to put in all the zeros for the trillions place or the quadrillions. We certainly don't want to count decimal places all the way to the billionth place. So we use scientific notation to help represent numbers in a more manageable way. So you'll notice this slide, we have 1.5 times 10 to the 4th. He's got, this green marker doesn't look good on this. Let's see if this guy looks a little better. A little better. Because the exponent is positive, notice 1.5 times 10 to the 4th power right here. This number is positive. So if this number is positive, we're thinking about a big number. So we want to move our decimal point backwards to make this number larger. So we're going to start here and we're going to count 1, 2, 3, 4 places. So the number we're actually looking at is 15,000. Add zeros to fill in the empty gaps. If you're looking at your scientific notation and you have a negative exponent, such as this one, 5.8 times 10 to the negative 4, well, this means that our number is super small. So we got to go to our decimal point and we move it the other way so that our number gets smaller. So it goes 1, 2, 3, 4, and we end up with 0.00058. Notice this, because the exponent is negative 4, move the decimal 4 places to the left, making your number smaller. Add in zeros to fill in the empty gaps. This is a two-way street. You may find numbers in this form, in 15,000, and they could ask you to go up to this direction. If that's the case, you start at the end of your number, or you find your decimal point, and you count until you get to one whole number, and then a decimal. So the idea is, and I'll show you here, with problem number 19.
You want to switch?
Yes, we can switch real quick. Problem number 19 from your practice test asked us to put this in scientific notation. Scientific notation. And we are asked to add 670 million plus 700 million, and they want our answer expressed in scientific notation. So adding has been just like it always was. 0 plus 0 plus 0 is still 0. 7 plus 0 is 7, and 6 plus 7 is 13. 1, 2, 3, 1, 2, 3, 1, 2, 3. So right there. So I have 1,370,000,000. That's my number, and represented in scientific notation, I go to my decimal point right here, and I count 1, 2, 3, 4, 5, 6, 7, 8, 9. And I write 1.37 times 10 to the 9th power. So there it is. That is the number 1,370,000,000. 370 million represented in scientific notation. So you can see this, you'll see this a couple of different ways. It may be given to you in scientific notation and you have to pull it out. It may be given to you in the form that it was here, in a standard form of numbers, and then you have to put it into scientific notation yourself. The idea is, though, is that you have one number, and then the decimal point, and then whatever's left over after that. Important to know that it's one number, then the decimal point, whatever that number may be. So that's scientific notation in a nutshell. Once again, if you guys are confused or have questions, please email me or bring them up in our time together. Bringing it back.
It'll take just a moment.
1 second.
There you are.
Haha. Hello. Everybody's favorite thing, ratios, percents, and proportions. Man, they are out there in the world, all of them. It feels like everything's proportional. I found this sweet little picture of these dogs. They're proportional. And the way we read this is 10 is to 20 as 15 is to 30. Notice 10 20ths is 1/2 equals 0.5 and 15 30ths is 0.5. There's two. So proportions are something that pop up in the exam a little bit. I always thought of these proportion problems as the problems that are like apples are to fruit as what is to a vegetable, right? And then you would be given the choices of dirt, brick, carrot, or hamburger. And of course the carrot is the vegetable. So apples are to fruit just as carrots are to vegetables. This is kind of a similar idea when it comes to numbers. 10 is to 20 as 15 is to 30. Why? Because 10 is half of 20 and 15 is half of 30. So when you're setting up your proportion problems, this is what they're going to look like. There's going to be a fraction equal to another fraction. And you're going to have to set it up and solve it. So let's work on one of our practice problems from our practice exam. Let me see if I can pick one that's proportional here. 3, 6, 21. Aha! Here's one, number 3 from our practice exam. Question number 3 here. I don't know if you can see it. Can we zoom in on that at all? Oh, look at that. Sweet. Perfect. So on a particular road map, 1/2 inch represents 18 miles. About how many miles apart are two towns that are 2.5 inches apart? So there's a couple of different ways that you can solve this problem. We know that 1/2 inch is 18 miles. You can look at this and do the basic operations and think, okay, I have how many 1/2 inches and 2.5 inches? Well, I have 5 1/2 inches, and multiply 5 by 18, and that would be your answer. But you could also set this up as a proportion. So I will show you as a proportion. It would be set up as 0.5 inches is to 18 miles as 2.5 inches is to what? So we're zoomed in a little bit there, but now you can see how I've set up a proportion. I've been told in my story problem that half an inch represents 18 miles, so I have half an inch is to 18 miles. And I've been told that two towns are 2.5 inches apart, so 2.5 inches is to how many miles? So if I want to solve these proportions, setting it up is one thing, and can sometimes be the harder part. But once it's set up, it's fairly easy to solve. Anytime you see that equal sign between two fractions, we cross multiply. So this is where you may have heard that term cross multiply. It's always over an equal sign, and it turns up in proportions.
Do you want to zoom it out again?
You can zoom it out a little bit, that'd be all right. So I'm going to multiply.
That's just,
Sorry,
that's that
just
button.
a button. Yeah.
Yep, there you go.
So I'm going to multiply, cross multiply these two things. So I have 18 times 2.5. And then I cross multiply this, that on the other side is equal to 0.5 question mark. And I'm trying to solve for my question mark here. 18 times 2.5 by calculator is 45 on the left-hand side of our equation. And we still have 0.5 question mark on the other side. We'll cancel out the 1/2. What we do to one side, we have to do to the other. So then our question mark is equal to 45 divided by 0.5. Which, by calculator, since you're allowed one, we should definitely be using them, is equal to 90. If we come back to our problem, we hope and pray that 90 is even a choice, because now I've solved this proportion. And if you look at that, you'll see right there, letter E is 90. So the two towns must be 90 miles apart. And that's how we use proportions to solve certain problems. Other things that are proportional that you'll run across are geometric shapes. Many geometric shapes that are proportional in lots of different ways, and I think there's some on the exam here. So for example, if I have a triangle, 90-degree triangle, and another 90-degree triangle, like so, and this side length is 8, and this side length is 17, and this side length is 51, then what is this side length? So I say to myself, 8 is to question mark, as 17 is to 51. 8 is to this side is to that side, as this side is to this side. Once again, it's not my proportion doesn't look the same as my last one, but solving it is the same idea. I multiply this side. 8 times 51 is equal to 17 times my question mark. 8 times 51 is 408. By calculator, I'm not that good at arithmetic. Divide by 17 on both sides, so our question mark then is equal to 408 divided by 17, which happens to be 24.
It's good enough, well.
Now that should make sense, because 17, or 51 rather, is 3 times bigger than 17. 17 times 3 equals 51. So this side is 3 times bigger. If the triangles are exactly the same, then this side better be 3 times bigger than that side. Well, 3 times 8, that's 24. So I know that I've done this correctly because 17 is to 51 as 8 is to 24. Proportions. Proportions pop up in lots of different ways. Story problems, geometry. It's important to be able to set up the problem, number one, and then solve it, number two. Again, ask questions if we are confused about proportions. Percentages is another big one. when we calculate percentages, they're kind of proportional, but percentages pop up every day in our world. I use a formula called base times some percent equals some amount. And the way I like to think about this is if I'm going to go buy a $100 pair of shoes and they are on sale for 10% off, well then what is the amount that I can take off my bill? Well, that's the $10 right there. Notice I didn't ask you what you're going to pay. I asked you what you're going to take off of your bill. There's no 90 in this formula, but the 100 starting minus the 10 is how you end up with the sale price of our shoes. But if I make sense of this formula, this means that with any numbers, they're going to be giving me either a base and a percent, and they're going to ask me for an amount. Or they'll give me an amount and a percent and ask me for a base. Or they'll give me a base and an amount and ask me for a percent. So there's keywords. Base's keyword is of. Amount's keyword is. And the percent keyword is, obviously, percent. So if I'm asked a question like, what is don't know if I want to just dive right into that or not really. All alone. Trying to think of what. 50.
Go back to your original problem and use the words.
100 or 10 is 10% of 100.
So what is 10% of?
Because there's three ways. So there's like what is 10% of 110? 20 is what percent of? There we go. That's what I was thinking. 20 is what percent of 50? So if I have a question like this is what I was thinking. 20 is what percent of 50? Obviously, when I set this problem, I have base times percent equals amount. In my formula, I see the word is, and I know that that's 20, because that's my amount, and is and amount go to it with each other, or is equal to, rather. And of is 50, so I know my base is 50. So now I'm looking to solve this problem. So 50 times some number equals 20. If I want to find out what that number is, I untie the multiplication here by dividing by 50. And keep algebra legal. What I do to one side, I have to do the other. So my percentage then is 20 out of 50, which happens to be 0.4, which equals 40%. Just to clarify, 20 divided by 50 is 0.4. And when I do percentages, I move the decimal place 2 spots. 1, 2 to the right. And we have 40%. So that's one version of that problem. You may also see 10% of 110 is. In that case, is what we're looking for. 110 is our base times 10% equals whatever we're looking for. To do this, to get rid of the percent sign, you always move the decimal. So we have 110 times 0.10. and that equals 11. So 11 is 10% of 110. And finally, the last thing they can ask you is what is the percent? Or not percent, well, what is the base? So 60% of what is 40? So three ways these percentage problems can be presented to you, generally. I mean, they can ask you lots of percentage problems, but for the basics, there's these three ways. So here I have see the word is, so I'm going to throw in 40 of what is my question, and I know that this is 0.5. Solve this problem, divide by 0.60 on both sides, and my base number then is 40 divided by 0.6, and I don't do that in my head because we have 1 minute to do these problems. 66.666. So 60% of 66.66 is equal to 40.
Make sure that stays. That's the microphone.
Oh, was it off?
No, but it was covered.
Oh, oops. Whoops. All right, so that covers proportions and percents. Again, if you guys have any questions, please send them to me or ask them for me. The last thing I have for you guys today is mean, median, and mode. This is simple probability and descriptive statistics. I feel like calculating the mean, median, and mode is pretty easy. There was 5 problems on the test for simple probability and descriptive statistics. I think this is important to know what the differences are. So the mean is the average. The mean is the average. And in order to calculate the average, you add up all of your data and you divide by the amount of data that you added up. That's calculating the mean, or the average. The median is the middle of the sorted data. And what I mean by sorted data is I mean you have your data and you sort it from least to greatest. And then you go and you find out which one is in the very middle. If you have an odd amount of data, say you have 11 pieces of information, then you want to go to the 6th piece of information, because there's 5 on each side of that, and that 6th piece is your median piece of information. If you have an even number amount of data, say you have 10 pieces of data, you need to go to 4 and 5 and average those two in order to get your median. Your mean and your median may not be actual data that you have. It doesn't mean that they have to be. You actually calculate those different things. And of course the mode is the most reoccurring data that you have. So the mode is the most. So we have the mean, the average, median, the middle. I think about median being the middle is when you're driving your car, you stay out of the median because it's the middle of the road. And then of course the mode is the most. One thing I did not put on here is the range. Range is important as well with descriptive statistics, but the range is going to be, once you sort your data from least to greatest, you want to take your largest minus your least, and that's your range of data. There's a few probability problems on here that we could go through if you guys are confused. And the descriptive statistics part of this is actually the mean, median, and mode. So if you guys have any questions or would like to run through those problems, please feel free to let me know via email or during our class time together, and we will hammer those out and answer any questions that you might have. All right. Thank you.
Thanks, Mr. Lewandowski. Awesome. Good job. We will have an email for you set up like Heather's.
Perfect.
So,
Inspired classroom.
Yeah,
Nice.
yeah. We'll get that set up, and I'll get in touch with Mrs. Kendall and the students, and hopefully we'll get this going. Thank you.
Yes, thank you.